Today we will be discussing some good questions on center of mass. So first question is, here's a sphere of radius r and its center is at 0, 0, and here's a small cavity is present, and this cavity is of radius r by 2. So we have to find the center of mass of this cavity, means the sphere like this, means the disk with this cavity, sorry, it's a sphere. So first we will assume that mass of this is m, means we have to find a relationship between the mass of the big sphere and the cavity which is cut out from it. So 4 by 3 by cube, it's the volume of big sphere, and 4 by 3 cube 1 by r by 2 cube is the volume of small sphere. So we found a relationship that volume of big 8 times the volume big is equal to volume of small sphere. So as we know, volume is directly proportional to mass. So if the mass of the small sphere is m, then this will be 8m is equal to small. Means if we assume the mass of this m, then this will be 8m. So we don't need the mass of this cavity. So we will write minus m, because we don't need it. So we will write minus m, its mass. It's a trick and it really helps to solve questions like this. And the mass of big sphere will be 8m. So as we know, x center of mass is equals to mass of this m1 into where its center of mass may be, where its center of mass would be, because we know from this, so 0 plus m minus m into the center of mass of this could be at r by 2 distance, means the x coordinate should be r by 2 on total mass. So we will get x center of mass from here. This is equals to minus m by 2 upon 7m. So it will be somewhat here, because it's a big, means it's a cavity. Here no mass is present, so it is possible to have a center of mass shifted here, because there only its center of mass would be. So the final answer of our question is this. So this is the answer. So this is how the question is. So let's move on to our next question. So our next question is here, find x center of mass and y center of mass. In this we have to find two center of masses at x axis and at y axis. Look at this slide. So this is given and the equation this is given, y is equals to this is given, and sigma given mass per unit area of this. So we have to find the center of x center of mass and y center of mass of this graph and this figure. So for this, first we know x center of mass. As we know here it is variable, so we have to use integration, and we know the formula for integration. It is integration x dm upon integration dm. Means x m1 x1 it is like this only, m1 x1, but as we know here it is variable, so we have to do integration, and it is m1 x1 plus m2 x2 plus of all this present in this range. So by using this formula, and for similarly for y center of mass, it is like this. Means y dm along y axis. So by using this formula, we can solve this question very easily. So first we'll find x center of mass. So for that, first we will find dm. So simply like this. Dm. So we will assume a small piece at x distance of dx width, and dm is equals to, so it is sigma mass per unit area and area of this portion. This is small piece. So as we know, area is width into height. So this will be dx into y. So putting y from this equation, we get dm is equals to sigma k x squared dx. So further integrating it, we have to integrate it from x coordinate 0 to a. So 0 to a. So we get sigma k r constant, so it will come out from integration, and integration of x squared dx is x cubed by 3. So we got our dm. So now we got our dm. Now we have to find x dm, this. So in this dm, we will multiply x. Integrating it from 0 to a, we get sigma k r constant, so it will come out, and integration of x cube is so from 2 and 3 we can find x center of mass. So let's write it here. So x center of mass is equals to this, means we will do 3 divided by 2. So it is sigma k, and we are putting a in this, as we know in definite integration how we do it. So it is a raised to power 4 upon 4 divided by this, here also sigma k a cubed by 3. So we get sigma cubed by 4 a4 into 3 by a cubed sigma cube. So we finally got an answer. X center of mass is equals to so this is our final answer for x center of mass. So x center of mass was easy. Now we will find y center of mass for this same figure. So So dm will be same. There's no difference in dm. So this is, so we need this equation. This equation is common for both. So now for y center of mass. So for finding y center of mass, first we will do this, and for y center of mass we have to find center of mass in y axis. So for that